Right, I'm beginning here now. So, right, remember before when we were doing, where did I put my sheet there now for that here? Right, remember before when we were doing calculus, right, and we were doing differentiation, we had our wordy type questions. And in our wordy type questions, if we got the word distance or height, right, we would differentiate that to get speed or velocity. You differentiate that to get your acceleration. If you're asked for the maximum height, you differentiate, put it equal 0, sub back to the original, double differentiate and sub in. So these were for our wordy questions. So we'll have kind of wordy type questions as well in integration. So in my integration, right, just have a look here at this kind of arrow diagram that I have made, right? So if I was asked for displacement, distance or height, they're all just words for the same thing. If I differentiated that, I got my speed or velocity, the two words for the same thing. If I differentiated that, I got acceleration. Okay, so this is the order that they would go in. Differentiate the displacement or the speed or the distance and you get speed or velocity. Differentiate that and you get acceleration. Now generally the letter used to denote speed or the letter used to denote distance or height is S. The letter used to denote velocity or speed is V, so don't get confused. You might think S would be speed, but it's not, it's V. And then acceleration. So obviously now in integration, if you'd wordy type questions, you work in the opposite direction. So you might be given acceleration. So to get back to your velocity or speed, you integrate. So to get from velocity to acceleration, you differentiate. To get from acceleration back to velocity or speed, you integrate. To get from velocity or speed back to the displacement or the distance, you integrate. And that's going back to our theory. Remember where we had, if we were given that dy dx is equal to a certain thing. When I integrate dy dx, I integrate the right hand side. When I integrate dy dx, I got y. So that's equal to the integral of whatever over here. Same way if you differentiate your velocity, you get acceleration. So remember, the relationship between the two of them, differentiate velocity or speed gives me, right, acceleration. Okay, so when you differentiate, dv dt is differentiate the velocity, it gives you the acceleration. So if I integrated dv dt, right, integrate at to keep them balanced. When you integrate dv dt, you get vt, which gives me the integrate at. So the velocity is equal to integrating acceleration. Okay, so that's your method. Same here. What's the relationship between distance and velocity? When you differentiate the distance, you get the velocity. When you integrate velocity, you get speed. So look here. When you differentiate the distance, you get velocity. So the distance is s, isn't it? So when I differentiate it, so differentiate the s with respect to time, that will give me the velocity. So if I integrate ds dt, I integrate the right hand side to keep it balanced. So when I integrate ds dt, that's st, which is your distance or your height, and it's equal to the derivative or the integral of vt. So that's what we'll be doing basing our questions around now when we're doing some examples. Now, where are my examples now? And I'll go back to them, right? So here are my examples, right? So example number 1. An object moves along a straight line and it has an acceleration is given by at is equal to 6t plus 40. Its initial velocity, so initial velocity, no time has passed, t is 0, is v0 is minus 60 centimeters per second. And its initial displacement, so again t is 0, from a fixed point is, displacement is the distance or the height, remember that while ago in our thing here, right? So even if you wanted to look, pause the video and take down this arrow diagram here. So you're going this way for differentiation and you're going back for integration. If you wanted to pause the video and take it down, all right? So we move then, right, if you've taken down, to find the velocity function and hence its speed after 10 seconds. Now velocity and speed being the same thing. So find the velocity. So what I need to do now is to find a relationship between the velocity and acceleration, which what was given. So what's the relationship? When I differentiate velocity, I'll get acceleration. So dv dt is equal to acceleration. So when I integrate dv dt, I integrate at. If I integrate dv dt, I get vt, and I integrate my acceleration. Now I know what acceleration is. I don't know yet what velocity or speed is, but I know the acceleration is at. So that's 6t plus 40, and I must integrate that. So when I integrate it, I will get 6t squared over 2 plus 40t plus c, the constant of integration. Don't forget that because we have no limits. So, because it's an indefinite integral. So it's 3t squared plus 40t plus c. Now, how do I find c? I know that, right, from the beginning of my question, the initial velocity is minus 60. So initial is when t is 0, the velocity is minus 60. So look here, my function vt is 3t squared plus 40t plus c. So when t is 0, v is minus 60. So minus 60, 3 by 0 squared, 40 by 0 plus c. So that's 0, 0. So c is minus 60. So the velocity is equal to 3t squared plus 40t, c is minus 60. Then it says find its speed after 10 seconds. So how would I find the speed after 10 seconds? 3 by 10 squared, 40 by 10 minus 60. Sub it in and get out your answer. Okay, I'll move on to the next one. Find its displacement function st, and hence find its distance from 0 after 10 seconds. So the displacement is the same as the first one here, which is your distance or height. The relationship is differentiate the displacement and you'll get velocity. So when I differentiate my displacement ds dt, I get velocity. So I'll work with this one up here because I know what velocity is now. So integrate ds dt, integrate vt. When you integrate ds dt, you get st, and that's equal to the integral of vt. So st is equal to integrating the velocity, which was 3t squared plus 40t minus 60. So st is equal to 3t cubed over 3, 40t squared over 2, minus 60t plus c, the constant of integration. Tidy that up, 3 into 3 is 3. So st is equal to t cubed plus 40 divided by 2 is 20t squared minus 60t plus c. How do I find my constant? Go back up and it says its initial displacement is 3. So initial is when t is 0. So when t is 0, the displacement is 3. st is equal to 3. So st is 3, 0 cubed, 20 by 0 squared, 60 by 0 plus c. So they all give 0, so c is 3. So st is equal to t cubed, 20t squared, minus 60t plus 3. Is that alright? And then it says find the distance after 10 seconds. So the distance after 10 seconds, sub in 10 and evaluate your answer. Okay, in your calculators. So that's that one done, right? So you can see the relationship being built between them. Look here at example number 2, and it says the speed of an object is given by v is equal to 4 sine of 3t, right? So this time v is 4 sine of 3t. Now this time I'm asked find the total distance travelled, so distance. So what's the relationship between distance and speed? So distance is ds dt. When I differentiate the distance, I will get my speed or velocity. So if I integrate ds dt, I integrate the right hand side. When you integrate ds dt, you get st. So it's integrating vt. Sorry, no, a second. Nice, as a reminder. So st is equal to integrating 4 sine 3t. So ST is equal to, now integrate 4 sine of 3t, and that's integrate sine and it's minus cos. So minus 4 cos of 3t over 3 plus c, the constant of integration. Okay? Right? Oh no, sorry, you were given limits here. Just say it so we've no constant. Sorry. Right? So when you have your values, sorry, I forgot to put them in, pi over 3 and 0. So this was more of a definite integral. So I'll now have minus 4 cos of 3, what is it, pi over 3 divided by 3, minus 4 cos of 3 by 0 over 3. So this is minus 4 times the cos of pi over 3 minus 4 times the cos of 0 all over 3. Now cos of pi is minus 1 as far as I know. So minus 4 by 1 over 3 minus 4 cos of 0 is 1 all over 3. So when I evaluate that, minus 4 all over 3, that's wrong there now. I'd say that should be a minus 1, is it? Oh, this one is minus 1 actually. Isn't it? Cos of pi is minus 1. So that's plus. And this is plus 4 all over 3. So my answer is 8 over 3 or 2 2/3. Okay? Right. The next thing then says, find the average speed of the object over this time. Now I know what the speed is. What's the speed? The speed is equal to up here. But how do I find average speed? If you recall, speed is equal to distance all over time. Right? What's the distance travelled? Find the total distance. The distance is 8 all over 3 meters. So it's 8 over 3 meters. And the time is, right, time was what? It started at t is 0, which is the initial, and it went up to pi all over 3. So the time was pi over 3. Right? So when you have that, 8 over 3, there's no pi there, right? Divide that by pi over 3. So 8 over 3 multiplied by 3 all over pi. Do you see what I'm doing here? Invert and multiply. So the 3's divide into each other and my answer is 8 all over pi. The average speed is 8 over pi meters per second. Is that okay? -1. Right. All right, so there are those ones. Now again, right, I'll mark some questions from your book for that for homework tonight.